Okay, so 2.2, we are talking about conditional statements. So conditional statements, you will be writing out sentences essentially. It is an if-then statement with a hypothesis and a conclusion. This should remind you of science a little bit and making your hypothesis in science. So it's a logical statement, two parts, a hypothesis and conclusion. That is where we do if-then form. The form of a conditional statement that uses the word if and then. The if part contains the hypothesis and the then part contains the conclusion. So if it is Wednesday, then I go to the mall. That is a if-then conditional statement, okay? The hypothesis specifically would be the if part. So if it is Wednesday, that is my hypothesis. My conclusion then would be, then I go to the mall. So the then part. Negating is making the opposite for both the hypothesis and the conclusion. So if I negated it, it'd be, if it is not Wednesday, then I do not go to the mall. We do shorthands for conditional statements. We say P, then Q. P stands for the hypothesis, Q stands for the conclusion. So if I was going to do a negating, it'd be not P, then not Q. Now, just as a side note, if one of them's already negated, so let's say my new statement, I'm going to start back at the conditional statement. If it's not Wednesday, then I will go to the mall. So if I negated both parts, I would be doing the opposite. So now I'd say, if it is Wednesday, then I'm not going to the mall, right? So if you negate something that's already negative, it becomes positive. So it's like your double negative in English. It's like your double negative in math. So converse, what a converse is doing Q then P. So it's actually taking your hypothesis or your conditional and flipping it around. Your if is still your first word. The then part still separates. The word then separates them, but it's flipping the ideas that came in the hypothesis and conclusion around. So if you remember, my conditional statement was, if it is Wednesday, then I go to the mall. If I'm doing the converse of that, I would say, if I go to the mall, then it is Wednesday. So I took the ideas in the hypothesis and conclusion and I flipped them around. A biconditional statement is our best definition if we can write it. You cannot always write a biconditional. A biconditional can be written if your conditional statement is true and if your converse are true. If both of those are true, then you can write a biconditional. So a biconditional takes out the if, it takes out the then, and in place of the then, it puts in if and only if. So let me think of a good... So if I have a quadrilateral, then I have a four-sided figure. That is true. Converse of that. If I have a four-sided, I'm going to stop. I'm going to go back. My conditional statement is, if I have a four-sided polygon, then I have a quadrilateral. True. Converse, if I have a quadrilateral, then I have a four-sided polygon. That is true also. So I can take my conditional statement of if I have a quadrilateral, then I have a four-sided polygon, and I can make it into a biconditional. I'm going to take out the if. I have a quadrilateral if and only if I have a four-sided polygon. Sorry, that took me a while to remember which one I said. So hopefully I said that correctly. So your conditional statement has to be true. Your converse has to be true. Then you can write your biconditional, which takes out the if, it takes out the then, and in place of the then, you put if and only if. Shorthand to that would be an IFF. If you don't want to write out if and only if, you can put IFF instead. Okay. Rewrite the conditional in if-then form. A lot of times, it's kind of confusing what part goes in the if and what part goes in the then part. So here are some tricks. If you see if it is at 6 p.m., then that would be your if part. You would take that and put it at the beginning. You also always want your conditional to be true. So if at all possible, you want it to write it the way that it makes it true in the if-then form. So it is time for dinner if it is 6 p.m. So my conditional statement would say, if it is 6 p.m., then it is time for dinner. Okay? There are 12 eggs if the carton is full. So I see an if there, so that's going to be my first part. That's my hypothesis reminder. So if the carton is full, then there are 12 eggs. An obtuse angle is an angle that measures more than 90 degrees and less than 180. So there's no if there, there's no then there. So let's think about the two different ways that I could write this. I could write it as if an angle is an obtuse angle, then it measures more than 90 and less than 180. That's true. Or maybe I write it as if an angle measures more than 90 and less than 180, then it is an obtuse angle. That is also true. So really on this one, you could write your conditional statement either way. The way I'm going to write it is if an angle is obtuse angle, because that's the part that I see first. So if an angle is an obtuse angle, then it measures more than 90 degrees and less than 180 degrees. A car runs when there is gas in the tank. So if a car runs, then there is gas in the tank, or if there is a gas in the tank, then the car runs. One of those is actually true, one is false. Think about which one would be true and which one would be false. So the true one is, if a car runs, then there is gas in the tank. Think in your head of a counterexample to prove it the other way around not true. If there was gas in the tank, then the car runs. And so we're going to write this as if the car runs, then there is gas in the tank. So if I would have wrote it the other way, if there is gas in the tank, then the car runs, does that mean that my car will always run even if there's gas in the tank? Couldn't there be another problem with my car? Like the battery could be dead, right? So that's my counterexample to that other one. That's proving it incorrect. So since this is a correct statement, we're going to write the if-then form using that part first. So write the converse of each statement. Remember, the converse takes your conditional statement and flips it around. So we still have if first. So this conditional says, if you like hockey, then you go to the hockey game. So I'm going to take this. If you go to the hockey game, then you like hockey. Which could be false, right? You may be there just because someone else is going there, your friends or your family's going there, right? All right. If x is odd, then 3x is also odd. So the converse, so if x is odd, so let's say we have 3, then 3x is odd. 3 times 3 is 9. Let's try another one. 5. 5 times 3 is 15. So that's actually true. Let's flip it around. If 3x is odd, 9, 15, 27, that means x is odd. That's also true. So this is a good definition. You could do a biconditional. So you could say x is odd if and only if 3x is odd. Okay, so if 3x is odd, then x is odd. All right, next page. Determine whether the statement is true or false. If it is false, provide a counterexample. All right, so we talked about counterexamples in 2.1. A counterexample proves something is false by giving an example of when it's not true. So if a polygon has 4 sides, then it is a square. So does that mean that all quadrilaterals are squares? That's what they're trying to say. But we know that that's not true. So for instance, we have a rectangle. We have a parallelogram. We have a rhombus. We have a trapezoid. All of those would be considered counterexamples, and they just ask for one. If the measure, so number 8, if the measure of angle A is 122 degrees, then the measure of its supplement is 58 degrees. So if we remember, supplementary angles add up to 180. So 122 plus 58 equals 180. So there's no other number that would add to 122 that would get us to 180. So this is true. I guess I need to write false up here too. And then there's my counterexample. When it rains, it pours. So that's making it, that is saying that if it is raining outside, then it has to be pouring down. Well, that would be false, right? Because what else could it be doing? It could be sprinkling. It could be a light rain. It could be like spitting, like barely raining, right? Any 4 collinear points are coplanar. So they're saying if I have 4 collinear points, then they're also on some plane together. Well, that's true, because if I can draw a line through them, and there's a plane that goes through them also, so that one would be true. Okay, so what I want for you to do is I want you to pause me, and I want you to do 11 through 14 on your own. It says write a converse for each true statement. If the converse is also true, combine the statements to write a true biconditional statement. We'll go through and do number 11 together. If an angle measures 30 degrees, then it is acute. That is true. Converse of that would be if an angle is acute, then it measures 30 degrees. Does that mean that all acute angles have to be 30 degrees? That's what it's trying to say. So that would be false. So since one is true and one is false, we need both of them to be true to write the biconditional. I cannot write the biconditional on that one. So go ahead and do 12, 13, and 14. Pause yourself. I'm going to pause myself, put in the answers, and then go over them quickly whenever I'm done. Okay, number 12. If 2 angles are supplementary, then their sum is 180. That is true. The converse of that would be if 2 angles sum is 180 degrees and they are supplementary, also true. So then I can write the biconditional. So 2 angles are supplementary if and only if their sum is 180 degrees. 13, if 2 circles have the same diameter, then they have the same circumference. That is true. If 2 circles have the same circumference, then they have the same diameter. That is also true. And so then I can write the biconditional. Remember, a biconditional is the best definition. So this would be the best definition of circumference and diameter, of circumference really. If 2 circles have the same diameter, if and only if they have the same circumference. Number 14, if an animal is a panther, then it lives in the forest. I said false on that because there's panthers at zoos, right? So that is my counterexample. The converse of that is if an animal is in the forest, then it is a panther. And I said false on that. Okay. You're going to go on to the second part of 2.2 notes, and then after that I will explain in the next video what you're going to do for 2.2.